In this lesson, we'll learn about comparing and ordering decimals. Let's start with comparing decimals. So just like when you compare whole numbers, the important thing in comparing numbers is to really pay attention to place value. And so we're going to start by using place value concepts to compare and order decimals. So our first task here is to order these three decimals, and I want you to just say them using your place value language in your mind. For example, instead of saying 0.835, okay, how would we read that using our place value language, using tenths, hundredths, or thousandths? So just think about it in your head. And did you say in your head 835 thousandths? If so, good for you. Move on to the next one. The next number we're going to compare is this one. Read it in your head. Did you say 2 and 641 thousandths? Awesome. And the last number we're going to compare is this number. So say it in your head using your place value language. Did you say 329 thousandths? Awesome. Remember, it's important to really enunciate that THS because that really signals the difference between thousands and thousandths. Okay, so these are the three numbers we're going to be comparing. Now you'll notice we were given this beautiful place value chart to use where the ones are labeled tenths, hundredths, thousandths. And of course the decimal point comes between the ones and the tenths. And so if we write or list these numbers we're comparing, placing each digit in the correct place value, then it really makes it easy for us to make some comparisons. Now that we have the place values lined up, we're ready to compare. So we always start in the largest place value. And so first we start comparing in the ones place. And we can see that 2 ones is greater than 0 ones. So we know that 2 and 641 thousandths is greater than 835 thousandths. And we know that 2 and 641 thousandths is greater than 329 thousandths. So this tells us that 2 and 641 thousandths is the greatest. So now we're left with, I'm going to cross it off because we know that's number 1. Now we know that we have the next two numbers to compare. So we're going to compare 835 thousandths with 329 thousandths. So we're done comparing in the ones place. We move on to the tenths place. So we can see that 8 tenths is greater than 3 tenths. And so that tells us that 835 thousandths is greater than 835 thousandths is greater than 329 thousandths. So now we know that 329 thousandths is the least. So if we were going to order these from least to greatest, we know the least is 329 thousandths. The greatest is 2 and 641 thousandths, leaving the middle number to be 835 thousandths. Now, the biggest mistake I see on comparing and ordering decimals is actually a reading error. It's when students list it from greatest to least instead of least to greatest. So I always encourage students to make a big notation to remind them, what order am I supposed to place these? Is it least to greatest or greatest to least? So make sure you're reading these problems. All right, let's look at another one together. We have 3 new numbers that we're going to compare. And again, I want you to first in your head, read them to yourselves. So first look at this number, read it in your head using your place value language. Read the second number in your head using your place value language. and then the last one. Okay, let's see if you were right. Was the first number you read, did you say 72 hundredths? I hope so. In the second one, did you say 273 thousandths? I hope so. And the last one, did you say 7/10ths? Awesome. Okay, so now that we've read these numbers and thought about their place value, we would plug them into our place value chart. Again, we have this beautiful chart drawn for us, and we can see that we have 72 hundredths recorded in our first row. We have 273 thousandths in our second row, and our last row we have 7/10ths. On that first row, I can't remember, did I say, I hope I said 72 hundredths. Anyway, okay, so we've got our place values lined up. We always start in the greatest place value. There are no ones, so we're going to move right over to the tenths. And so we can see that we have two numbers that have 7/10ths and one that has 2/10ths. So right away we see the lowest, right? So 273 thousandths is going to be the littlest. But we need to compare into the hundredths to see, we're done with that one, to see which one is greater. So this hundredths, we have 2 hundredths, and here we have 0 hundredths. So we can see that the greatest now is going to be 72 hundredths, and the middle number will be 7/10ths. Now, careful reading reminds me that I need to list it from greatest to least. So to list these from greatest to least would be 72 hundredths, 7/10ths, 273 thousandths. Now, in our last problems, we've had these beautiful place value charts that we've been able to use to plug in our decimals to make some easy comparisons. But if you are having to compare two decimals and you don't have the place value chart, what can you do? Well, I would just personally draw one or a sketch one to the side. And so I would simply do ones, tenths, hundredths, and thousandths, okay? And these, of course, are just abbreviations, right? O for ones, tenths, a T and a THS for tenths, an H and a THS for hundredths, and thousandths, I ran out of space, but I would do a TH, THS for thousandths. And then I can easily plug in the numbers that I need to compare. So if I were comparing 12 thousandths, I can plug that number in, 0.012, compared with 12 hundredths, 0.12. And then I can start comparing in the greatest place value, and that would be tenths, because there are no ones. So if I look in the tenths, I can see that 12 hundredths has 1/10, 12 thousandths has no tenths. So I can see that 12 hundredths is going to be greater. So we would say 0.12 is greater. Let's look at number 2. We have 505 thousandths compared to 55 hundredths. So we can plug those numbers in, 0.505 and 0.55. And again, we start in the tenths place. That is the largest place value. And we can see that they both have 5/10ths. And so they're both equal in the tenths place. So we need to move on to the hundredths. We see that one has 5 hundredths and one has 0 hundredths. And so right there we can see that the greater number is going to be 55 hundredths, because it has 5 hundredths and the other number has 0 hundredths. So the greater number would be 55 hundredths. So we have our little friend here reminding us to use place value charts to help you compare these decimals. So if you don't have, or if you're not given a beautiful place value chart to plug your thinking in, jot one down on your own. In fact, using a piece of paper or something you have to write on, I would like for you to compare and order the decimals in number 3 and number 4. And we are writing these from least to greatest. So make a place value chart, plug in the numbers, lining up the place values, and see how you would list these from least to greatest. I would pause the video and then check back to see if your thinking matches mine. Okay, so I hope you made a place value chart so you could plug in these decimals. And so we have 7 tenths, we had 18 hundredths, and 315 thousandths. Now, some mistakes that I've seen some kids make is they look for the longest number and they think that's the biggest number. Can you just make that assumption just by glancing at these numbers? No, the longest number is not always the biggest number, especially when we're working with decimals. They might look and say, oh, I see 315, and I know 315 is bigger than 18 or 7. Again, that's not how comparing numbers works. We really have to look to see what the digits are in each place value. So let's begin by looking at the biggest place value. And the biggest place value that we have is the tenths place with these 3 numbers. And I can see that all the digits are different. So really, we're going to be able to make our comparisons here in the thousandths. And I believe we were listing these, yes, least to greatest. So let's come back and we're going to do it from least to greatest. So the lowest number is going to be 18 hundredths because that's the one that has a 1 in the tenths place. So we have 0.18. And remember that we separate a list of numbers with commas to separate the numbers. The next biggest number will be 315 thousandths, so 0.315, comma, and the largest number was 0.7 or 7 tenths. And we got that all from the tenths place. All right, we are now ready to compare our next 3 numbers. We have 19 hundredths, 2 tenths, and 185 thousandths. So we know the smartest way to compare these numbers is to line them up by place values. So let's go ahead and place them in our place value chart. And we have 2 tenths and 0.185. We always start in the largest place value, and in this case it will be hundredths because it will be tenths because there are no ones. So we can see that right now we can see the greatest number, right? Because 2 tenths is greater than 1 tenth. So we know that 2 tenths is going to be the number that is greatest. And now we just need to compare 19 hundredths and 185 thousandths to see what is the next greatest number. So let's compare in the hundredths place. We have 9 hundredths and 8 hundredths. So the lowest will be 8 hundredths, so it's 185 thousandths is going to be the littlest number, and then 19 hundredths will be the middle number. So now we just simply have to list these in that order. So 0.185, comma, 0.19, comma, and 0.2. These numbers are listed from least to greatest. Now the other part of our lesson is rounding decimals. We round decimals the same way that we round whole numbers, but let's just review what that means. So the first task asks us to round 14 thousandths to the nearest hundredth. All right, so the first way of thinking about this is to think about this on a number line. We know that 14 hundredths would come between 100th and 200ths on a number line. And that's what this number line is showing you right here. So here's 100th, 200ths, and right in the middle would be 15 thousandths. And so we have 14 thousandths just to the left of 15. Now you might be wondering too, how did we know that middle was 15 thousandths? Well, if this is, we could say this is 10 thousandths. 10 thousandths is the same as 100th. So we could say this is 10 thousandths. That would make this 11 thousandths. And this one would be, 12 thousandths. So this would be 13 thousandths. And there's 14 thousandths. 15 thousandths, 16 thousandths, 17 thousandths, 18 thousandths, 19 thousandths, and then we would have 20 thousandths or 200ths. Okay, so that's how we knew 15 thousandths was right in the middle, which then put 14 thousandths right to the left. Now, all that said, we can see that 14 thousandths is closer to 100th than it is to 200ths. We can just see that distance is shorter. And last year we talked about actually bending that number line, remember? And so I kind of like that idea of the bent number line. Let's make the bend right in the middle, right? So it would curve down, and if we were to place that a ball, or remember last year meatballs, Meatball Mountain, if we were to place a ball on that line, it's going to roll down towards the 100th, right? And so we can just physically see that when 14 thousandths is rounded to the nearest hundredth, it's going to be closer to 100. Now, another way of thinking about this, if you don't want to picture it on the number line, you can also say, okay, I'm rounding to the hundredths place. So I would underline the place value, the hundredths place value. There's the hundredths. And then last year we drew that back door, right? And we would say, okay, what number is knocking on the back door? Or who's knocking on the back door? And we can see that 4 is knocking at the back door. And we had that little phrase, 5 or above, we give it a shove. 4 or less, let it rest. So 5 or above, we give it a shove. 4 or less, we let it rest. Okay, so 4 is knocking on the back door, so we know we're going to let that number that's underlined in the hundredths place rest. So everything inside the house, remember we said this is our little house with our back door, everything inside the house would stay, and everything outside the house goes away or becomes a 0, right? So 0.014 rounded to the nearest hundredth would be 0.01. Let's look at this next one. It says round 2 and 345 thousandths to the nearest hundredth. So we can see on the number line that 2 and 345 thousandths comes right between, right in the middle of 2 and 34 hundredths and 2 and 35 hundredths. So because it's exactly halfway between, we would round to the greater hundredth, 2 and 35 hundredths. Another way of thinking about this, though, is also to underline the place value to which you're rounding. We'd underline the 4 because we're rounding to the hundredths. And then we could draw that back door and let's try that a little bit thinner. There we go. Draw that back door and we can say, okay, who's knocking at the back door? We have 5, And we remember our saying, 5 or above, we give it a shove. 4 or less, we let it rest. And so we can see that 5 is 5 or above. So we're going to give that 4 a shove. So everything inside the house stays. That 4 gets shoved up to a 5. And everything outside the house goes away. So 2 and 345 thousandths would round to 2 and 35 hundredths when rounding to the nearest. All right, I would like you to try these next two on your own. It says round each number to the nearest whole number, nearest tenth, and nearest hundredth. So for each of these numbers, you're going to have 3 times that you round. So the first one is going to be to the nearest whole number. The next one will be to the nearest tenth, and the last one will be to the nearest hundredth. Now, when we're talking about to the nearest whole number, we're talking about rounding to the ones place. So the ones place we would underline, and then we could draw our back door. The tenths place, a reminder where the tenths place is. In this case, the 0 was there. We could draw our back door. And then the hundredths place, draw your back door. So you're going to have 3 different numbers for number 10, and then 3 different rounded numbers for number 11. So go ahead and do your thinking, and then check back to see if you're thinking. So in number 10, we're looking at 2 and 29 thousandths. Let's start by rounding to the nearest whole number. We'd underline the number in the ones place, draw our back door, and we can see that 0 is knocking on the back door. Remember, 5 or above, give it a shove. 4 or less, let it rest. So 0 is 4 or less, so we're just going to let that 2 rest. So round it to the nearest whole number. 2 and 29 thousandths would be 2. Now let's round it to the nearest tenth. So underlining the tenths place, drawing our back door. We have 2 knocking on the back door, and 2 is 4 or less, so we're going to let it rest. So rounded to the nearest tenth would be 2.0. And rounding to the nearest hundredth, we would underline the hundredths place, draw our back door. 9 is knocking on the back door, and because 9 is 5 or above, we're going to give that 2 a shove. So that 2 would become a 3. We would round to 3 hundredths. So it's 2 and 3 hundredths, or 2.03. Let's look at number 11. The number that we're rounding is 25 and 957 thousandths. So rounded to the nearest whole number is the ones place. So we'd underline the ones place and draw our back door. 9 is knocking at the back door, so we say 5 or above, give that 5 a shove. So rounded to the nearest whole number would be 26. And now let's round to the nearest tenth. We'd underline the 9, draw our back door. We have 5 knocking at the back door. It is 5 or above. We give it a shove. So that 9 would become a 10, but we can't have a 10 listed there. So rounded to the nearest tenths would actually be 26.0. And rounding to the nearest hundredth, we'd underline the number in the hundredths place, draw our back door, and 7 is knocking at the back door, so 5 or above, we give that 5 a shove, and so rounded to the nearest hundredth would be 25.96, 25 and 96 hundredths. So in today's lesson, we learned about comparing and ordering decimals. It's very important to line the decimals up by place value and start comparing in the largest And we also learned about rounding decimals to the nearest whole number, nearest tenth, nearest hundredth.